Hello students, greetings of the day. In today's lecture, we are going to discuss a topic that is static member functions and variables. So to discuss this static member functions and the variables, we are just going to discuss this with the help of some subtopics. Okay. So in today's lecture, we are going to cover our today's topic with the help of these subtopics. In that, first we are having static keyword, then we are having static variables. After that, we are going to have the static functions, and then we are going to discuss the inline functions and friend functions. Okay, so let us start with the static keyword. This static keyword is nothing but a keyword that is going to be used in our C++ programming language to give a special characteristics to an element. Then that can be a variable, or that can be a method, that can be a data member function, or data member of your class, or can be a method or the member function of your class. So with the help of this static keyword, we are just going to provide some kind of special characteristics that to an element. Okay. So these static elements are going to allocate the storage only once in our program lifetime. Okay, means whenever I am going to declare a data member as a static data member, at that time that data member is going to be allocated a storage only once in a program's lifetime, right? And that will be a static storage area. Means that storage area, that memory allocation that we have made is not going to be changed throughout our program. So we are not going to change that storage that we have allocated for that particular element, right? So they have a scope, that static element that we have declared have the scope till the end of our program. Means it has the scope of our program's lifetime. So this static keyword can be used with the following. We can use such a kind of static keywords with the static variables in our function. Then that can be used with the static class object, then static member variables inside our class, and the static methods inside our class. So we can use these static keywords with the variables, with our class objects, with our member variables that we are going to use in class, right? So we can just use it with the methods also, right? So this is nothing but the static keyword and the use of that static keyword that we can make with the help of that keyword. Then we are having the static keywords has the different meaning when they are used with different types, right? In the previous slide, we just discussed that it has the four types: the variables in functions, then class objects, then member variables in class, and methods in class. So every time the static keyword is going to have the different meaning. That is when used with different types. So we can just use the static keyword with static variables and static members of class. So whenever we are going to use these static keyword with static variables, that is nothing but variables in a function and variables in a class. So it is going to have the different meaning. Whenever I am going to use the static keyword with variables inside a function, that is going to have different meaning than that variables that are in class. So same for our static members of our class. If I am using this static keyword with the class object, that is going to have the different meaning than that is with the function that inside the class. Okay, so this is nothing but the use of static keyword with the different member functions or the classes or the data members. So let us discuss that how this static keyword can be used with the variables. Okay. Here we are going to discuss the use of that static keyword with the variables. So when a variable is declared as an static, a space for its get allocated for the lifetime of our program. Right? Suppose I am having one variable, data variable, which is declared as static. So whenever I am going to declare that variable as static, a particular memory is going to be allocated for this variable, and the scope for that memory or the scope of that memory is throughout the lifetime of that program. So even if in the function is called multiple times, or the space for that static variable is allocated only once, right? So even if we are going to call that function multiple times, the space for that static variable is going to allocated only once. We are not going to allocate the memory for that particular static variable each and every time. And the value of that variable in the previous call gets carried through the next function call. Means every time we are going to call that variable or the function, at that time the value of that variable in the previous call gets carried out through the next function call. So the values are going to be updated, but the variable that variable has been allocated the memory, that is not going to be changed. Okay, so we are not going to allocate the memory each time whenever that function is going to be called. So this is useful for implementing the coroutines that we are having in our C++ programming, or any other applications where previous state of function needs to be stored. In such a cases, we can just implement such a kind of static keyword in our use. So this is static variable. Here we are having some example, one example of that static variable, use of static variable. With the help of this example, we can just understand that how the static variable are going to be used in the programs and how they are going to be implemented. So we are having one class, that is one program we are having directly. Okay, so here we don't have created class and all that thing. So here we are having write demo method or function. In that we are having the static int count is equal to 0, right? So here we have just declared one count variable of type integer, and we just use it as a static. Means this count variable that we are having is going to be allocated memory only once throughout the lifespan of our program, right? So at the initial stage, whenever we are going to initialize value 0 to this count variable, at that time that memory that it has been allocated, that memory is going to be continue for throughout the program. That memory allocation is not going to be changed throughout the program in this program. Okay, so static int count is equal to 0 that we are having. Then we are just going to see out count, the value that we are having, we are going to print out. So value is going to be updated and will be carried to the next function's call. Here we are going to increment the value that we are having in this count. So count plus plus. Okay. So every time that value is going to be changed. So we are having main function here. With the help of this main function, we have created one for loop in which initially integer I is equal to 0. We just have checked that I is less than 5 and I plus plus. So every time this condition is true, we are going to call the demo. So when I is equal to 0, we are just going to call this demo method. Whenever I am going to call this demo method, we are having initially count as a 0 that we are going to print. So count, the output is going to, we are going to have at our console screen is printed with 0. Okay. So with the help of this statement, we are having 0 as an output at our console screen. Then we are going to update the value of this cout count. Okay, initially it was 0, now it is 1. Count plus plus is nothing but we are going to update the value, increment the value by 1 that we are having. So now it is going to change with 0 to 1. Okay, so this is nothing but the instructions that are followed by the demo function. So we just have one time we have just implemented this, and we are having output as a 0 and the new value of count as an 1 with us, right? Then the value of this I is going to be incremented. So 1 which is less than 5, right? So again it is going to be called. Okay, so demo we are going to call it. So with the help of this, again we are going to have the new value of count is nothing but 1. We are going to print that value and it is going to be incremented. So with the help of this for function or the for loop, we are going to have the values of that count from 0 to 4, right? So output that we are going to get is 0 to 4, the 5 values we are going to get. So this is nothing but the use of static. So with the help of this static keyword, what we have implemented, we just have implemented a space that we have allocated for that function only once, but the previous value of that variable count is carried out through the next function call. Okay. So this is nothing but the example of static variable that we can have. Then next we are having is static function. So just like that static data members or the static variables inside our class, the static member functions also does not depend on the object of our class. Okay, so we are just allowed to invoke the static member functions by using the objects and the dot operator. But it is always recommended to invoke that static members by using the class name and the scope resolution operator that we are having. So while having the static member functions or the static functions in our class, we are just going to use the scope resolution operator, or we are just going to use the dot operator that we are having while using the objects. So the static member functions that are allowed to access only the static members or other static member functions, they are not, or they cannot access the non-static data members or the member functions of our class. So here is one example. We are having class GFE, right? In that we are having static member function, that is static void print message, and we are having main function, right? So to use or to make use of that static member function, we just have implemented or we just have used the scope resolution operator. With the help of this scope resolution operator and the class name in which we have implemented that static member function, we can just make use of that static member function. So the output that we are going to receive with the help of this statement is nothing but we are going to call the static member function from class GFG, and we are just going to have the output as an welcome to GFG at our console screen. Then next we are having is inline functions. Okay, so inline functions are nothing but the actual functions that we are having, which are copied everywhere during the compilation, right? Like the preprocessor macro. So the overhead of function calling is reduced. Okay, so such a kind of inline functions are just going to be copied everywhere whenever we are going to have the use of that functions. So all the functions that are defined inside our class definitions are by default inline, right? Whenever you are going to define a class, in that you are going to have some kind of data members and you are going to have member functions. So every time that member function that you are going to define inside that class are by default inline functions. But we can also make any non-class function inline by using a keyword inline with it. So if I am having some function that is not within that class, but I want to make that function as a member of that particular class, at that time I can just use one keyword that is nothing but inline, right? So I'm just going to have that inline keyword before that function definition, and that particular function is going to be as a part of that particular class. Okay, so for an inline function, declaration and definition, everything must be together. For example, that we are having, that is inline while fun int a, and into curly braces we are just having some kind of instructions, so return a plus plus. So this is the function which is not a part of a particular class, and you want to make it as a part of particular class. So what we are going to do, you are just going to use this inline keyword or the inline word before that particular function, and that function is going to be a part of that particular class. Okay, so this is nothing but the inline function. So there are some important points that we can have about the inline function. So first is there, that is we must keep inline functions small. Small inline functions have the better efficiency. So if you are going to have the inline functions complicated, that can affect on the efficiency of the working of that program. The second thing that we should know is inline functions do increase the efficiency, but we should not make all the functions inline, right? So because if we make large functions inline, it may lead to the code board and might affect the speed also. So whenever you are going to have such a kind of inline function, we just have to take care that we can just make use of 2 or 3 functions we can make inline, but we just don't have to make every function as an inline. So it can affect on the code board and it can also affect on the speed of our execution. So hence it is always advised to define the large functions outside the class definition using the scope resolution operator. Because if we define such a functions inside class definitions, they are going to become inline automatically. So the big different types of functions that we can have inside the class, we are just going to use, we are just going to define them outside the class, and we are just going to have the scope resolution operator. Okay. Then next we are having is inline functions are kept in the symbol table by the compiler, and all the call for such a functions is taken care at compile time. So inline functions are going to be kept in the inside the symbol table by the compiler, and all the call for such a type of functions are going to be taken care at compile time. Every time we are going to compile, those functions are going to be called. Okay, so this is nothing but there are different important points that we should know about inline functions. Then we are having another point, that is friend function. A friend function can access the private as well as protected data of a class, right? So we declared a friend function by using the friend keyword inside the body of our class. So we are having class name, right? In that friend return type function name, right? So this is nothing but a function that we just have converted as a friend function, right? So whenever we are going to use this friend function, that particular function is going to be assessed by the private and protected data of a class. Okay, so this is the friend function. Okay, so with the help of this friend function, we can just provide and access to that function by a private and protected data members of our class. Okay, so this is friend function. Okay, so this is all about our today's lecture. So in today's topic, we just discuss the different points which are related to the static member functions and variables with the help of static keyword subtopic. Then we discuss static members, static variables, then static methods, and at the end of this lecture, we just discuss the inline functions and our friend functions. Okay, so this is all about our today's topic. So in today's lecture, we are just going to end out the session. In next lecture, we are going to discuss the another topic from our object-oriented programming language. Okay, thank you very much.